Good afternoon, everybody. This is Mr. Varon with the solution for the problem of the day from March 31st. So this problem was Miss Taylor is playing a number game with one of her students. When the student tells Miss Taylor a number, Miss Taylor uses a rule to determine a new number. Miss Taylor always uses the same rule. The table below shows some of the students' numbers and Miss Taylor's numbers. So if we look at the table, we have the student numbers on the left, Miss Taylor's numbers on the right. So the student number is 5, Miss Taylor number is 16. When the student's number is 8, Miss Taylor's number is 25. When the student's number is 1, Miss Taylor's number is 4. When the student's number is 4, Miss Taylor's number is 13. And when the student's number is 2, Miss Taylor's number is 7. So if we look at our questions, part A, what should be Miss Taylor's number when the student's number is 6? Part B, when the student tells Miss Taylor a number, what is the rule that Miss Taylor uses to determine her number? And then part C, if the student's numbers are always whole numbers, could 43 be one of Miss Taylor's numbers? Sure, explain how you get your answer. So the first thing I want to talk about before we go to the solution is this table is actually called an input-output table. So if we're looking at this, the input is the student numbers. The output is Miss Taylor's numbers. A lot of times when we start with input-output tables, we label this as an X and a Y. Now we do that because that leads into coordinates. So X is going to be our input, okay, Y is going to be our output. So let's go look at the solutions. So the first thing I did was I took the original table. If we look up here at the top, okay, this is the original table, and what I actually did was I put that X and that Y underneath there, because again, with an input-output table, our X is usually what we use as a variable for our input, and our Y is our variable for an output. Now, those of you that don't know what a variable is, it's basically just a letter that stands for a number. So in this case, X is always going to be our student's number, Y is always going to be what Miss Taylor's number is. Now, what I've actually done here, when I make this chart, you notice up here they're not in order and there are numbers missing. So when I made the input-output table down below, so again, this represents the students' numbers, this would be Miss Taylor's numbers. I went 1 all the way through 8. Now why? Because 1 was my smallest number, 8 was my largest number for my students. So again, I want to actually fill in the missing numbers as I go. Now our output becomes Miss Taylor's numbers. Now the ones that I circled were the ones that would be missing. Now, the important thing to notice with an input-output table is you're going to see a few patterns emerge as we do this. So the first thing is you're going to notice that our inputs in this case are always increasing by 1. So it's a +1 pattern as we're going down our inputs. Now, when we look at our outputs, okay, we see that there's a +3 pattern. So if we look at this, we have 4, 4 plus 3 is 7, 7 plus 3 gets me that missing number of 10, which was for when the student's number is 3, Miss Taylor's number is going to be 10. 13 was given to us, 16 was given to us. Again, we add 3 to the 16, gets us to 19. So that's going to actually help us answer part A. So when the student's number is 6, okay, Miss Taylor's number is going to be 19. And then we get to 7, be 22, okay, 8, and 25 were already given. Now, these are two patterns that emerge, okay, as we're filling out this input-output table. However, when we get to question B, what they actually want to know is, what do I have to do to my X input in order to get my Y output? So these are not the actual answers for part B, even though these are patterns, they're actually not what they're looking for part B. Okay, part B gets a little bit more complex than that. So as I said before, if we look over here at our answers, so part A, the student's number was 6. What is Miss Taylor's number is going to be? 19. Now we figured that out using the pattern that we see here. Now ideally on this problem, part B could possibly be answered first because you have to determine a rule to even get to Miss Taylor's number. So if you look here, I determine the rule as we're going to take whatever our input is, X, times 3 plus 1 will get our Y, which in this case is going to be Miss Taylor's number. Now, how did I come up with that? So when I go back and I look at this chart, a few things I want to talk about in my mathematical thinking. So first thing I notice is my numbers are getting bigger. Now that's important when working with whole numbers, because typically if we're working with whole numbers, our processes such as addition and multiplication are going to get us bigger numbers, and things like subtraction and division are going to get us smaller numbers. Now I say typically, that only works with whole numbers. When we start getting into decimals and fractions, as I like to tell my fifth graders, unfortunately your third and fourth grade teachers sometimes lie to you by accident. It's not always the case. So when we multiply fractions that are less than 1 or decimals that are less than 1, we actually end up with smaller numbers. But in this case, since all of our inputs are whole numbers, okay, all of our outputs are getting bigger. So I can already start thinking about this as I need my numbers to get bigger, so I'm going to do some type of multiplication or addition, or a combination in this case of both. So when I look at this, the first thing I want to look at is this first one that was given to us. So when the student said the number 1, Miss Taylor gave the number 4. Now when I'm looking at that, there's two possible things that come to my mind right away. I could add 3 to 1 to get to 4, or I could multiply 1 times 4 to get to 4. Now here's the key. If that is going to be the rule that I come up with, it has to work for all numbers. So let's take the plus 3 part. So if I look at this, 1 plus 3 is 4, but if I look here, 2 plus 3 does not equal 7. So the plus 3 rule does not work. Now when I go to the multiplication, same thing, I go to 1 times 4 equals 4, but 2 times 4 does not equal 7. So that's where we run into the issue. So right away, I know it's not going to be just an addition or a multiplication problem. So now we got to think about what could be our possible options. So I just like to go through. So I did 1 times 2 to start off with. Okay, what would I have to add to 2 to get to 4 plus 2? So it'd be a times 2 plus 2. But as we see, that does not work for all of it, because 2 times 2 is 4. 4 plus 2 is 6, not 7. So that doesn't work. So then I went to a times 3 pattern. Now when I do this, we end up finding our answer. So if I do 1 times 3 is 3, plus 1 gets me to my 4. Now I got to see, does that work for all inputs and outputs? So 2 times 3 is 6. 6 plus 1 is 7. So that's one of the ones that were given. The other one that was given was the 4. 4 times 3 is 12. 12 plus 1 is 13. The 5 was another one given. 5 times 3 is 15, plus 1 equals 16. These were two that we added on using the table. The other one that was given was 8. So 8 times 3 is 24, plus the 1 is 25. So that's how I come up with my rule of times 3 plus 1 as my pattern. So again, this is going to be a 2-step pattern. So again, the rule here, what they're looking for is a times 3 plus 1 pattern. Now, when we get to part C, so they basically gave you the answer. So they're saying here, if we're looking at this equation that I have here, whatever the input was, so we don't know what the student's number was, but we know that our rule is times 3 plus 1, and we know that Miss Taylor's number is 43. They're saying, is this possible to get an answer of 43? Well, in order to do this, I really want to do the inverse. We've talked about that during one of our other problems before. So in order to do the inverse, when I have the answer and I'm trying to go and find out what I started with, I really got to work backwards. So I'm going to first do 43 minus 1 and then get that answer. That's why I have that in parentheses, because I'm going to do that part first. I'm going to get that answer and then divide it by 3 and see if I can come up with a whole number to start off with. So when I do 43 minus 1, I end up with 42. So now I have 42 divided by 3. And when we do the division over here, if I have 4, how many groups of 3 can I make? 1. I do 4 minus 3 is 1. I bring down the 2. So now I have 12. 12 divided by 3 ends up equaling 4. And when I subtract 12, I have nothing left over. So the answer to this, the student's number would be 14. So is it possible that Miss Taylor had the number of 43? Yes. Now why did it work? Because we ended up with a whole number as an answer. Now if we didn't end up with a whole number, we ended up with something with a remainder here, then that would not be a possible option. So again, this is a good intro to input-output tables and using patterns in those tables. And again, this ends up leading to graphing coordinates and all other things that we do in the 5th grade. Stay tuned for today's problem of the day, which will be posted shortly. Have a great afternoon, and thank you, everyone. Bye.